Okay, Wildcats. Today we're looking at Thursday, August 23rd, parent function foldable, and that's going to be on page 2. Now, I'm going to make the video, but you're going to use the video for Thursday and Friday. So I recommend watching half the video on for Thursday and the other half for Friday. Or you can just watch the whole thing. But either way, you're going to have 2 days to complete this parent function foldable, okay? So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the parent function foldable. Now, what you want to do first is on a separate sheet of paper, write parent function foldable on page 2. Because what you're going to do is you're going to glue or tape that to this page so you can put it in your journal, okay? All right, let's get to how to make the parent function foldable. So you should have these 5 pages, okay? So to do this, what you do is you line up this page first on this line. This black line is key. So the bottom of the parent function page here. And let's see if I can separate them a little bit before we go on. All right. So then next, keeping this lined up, you're going to line the linear page on the black line, the bottom of it on the black line. Okay. Then you're going to line the quadratic page from the bottom to the cubic. Okay. And then you're going to line the cubic up with the exponential. All right. Once you have that, you're going to bend down. So down. And then you're going to put, so the exponential lines up on the logarithmic page. Okay. So if you do it correctly, you have all 9 parent functions listed like this. Okay. Kind of make sure that that's all nice and crisp there. And staple here. And staple here. Okay. All right. So now this is nice and, I guess, like smooth, stapled, however you want to say it. But either way, it should look good. And you're ready to do your parent function foldable. Okay. So I've taken one and I've kind of pre-written some things out to kind of help shorten the video a little bit. So as you go along, you're going to have to just update each page, okay? First things first, we're going to go to the linear. All right, now you're going to need to add domain and range, inequality, and interval to each of the pages, okay? Now for this one, go ahead and do x, f of x equals x, and then the x values, okay? So I'll give you a minute to do so. Not actually a minute, that's a long time, like maybe 10 seconds. All right, now you have that. Let's look at the linear parent function, okay? So notice it says f of x here. That means whatever the x is what goes in next here. So this would be f of -2. Since x is -2, that means this x is -2. Okay? So that point is -2, -2. Okay, now f of -1. So that's f of -1 equals -1. So that's -1, -1. F of 0 equals 0, so 0, 0. F of 1 equals 1, so 1, 1. And then f of 2 equals 2. So 2, 2. All right, so then draw your line. All right, so now the domain in inequality notation is all real numbers. Okay, now in interval notation, we write that as -infinity to positive infinity. And that's because from left to right, this graph is going infinite in both directions. And it's also from bottom to top for range, it's going infinite in both directions. So it's all real numbers, -infinity to positive infinity. All right, it's a linear function, so that's f of x equals x. All right, so take a few seconds to update the linear parent function. All right, now your linear parent function is updated. Let's look at the quadratic. And again, you need to add domain and range inequality interval notation. All right, so we're looking at quadratic. So that's f of x equals x squared. I'm going to use x values -2, -1, 0, 1, 2. So same thing, the -2 goes in for x and goes into x here. So that's f of -2 equals -2 squared, which equals 4. So your point is -2, 1, 2, 1, 2, 3, 4. Okay, next point, f of -1 equals -1 squared, which equals 1. So that point is -1, 1. And we do f of 0 equals 0 squared, which equals 0. So your point is 0, 0. Okay, and then we do f of 1 equals 1 squared, which equals 1. So your point is 1, 1. And then last, f of 2 equals 2 squared, which equals 4. So 2, 1, 2, 3, 4. All right, so connect your points to form the curve. All right, so for domain and range. Domain, from left to right, it's going infinite in both directions, so it's all real numbers. In interval notation, that is -infinity to positive infinity. And then range, bottom, it starts at 0 and it's greater than, so the range is y greater than or equal to 0. It includes 0 because there's a point there. Now range, that's bracket 0 to infinity in interval notation. And then the quadratic is f of x equals x squared. All right, so now let's look at the next one. All right, and again, you need to add domain and range, inequality, and interval notation. And now let's look at cubic. So x and f of x equals x cubed. So again, when x is -2, it goes in for x, which goes in for the x here. So that's f of -2 equals parentheses -2 cubed, which is -8. So that point is -2, 1, 2, 3, 4, 5, 6, 7, 8. You kind of just approximate the point. So -1. So f of -1 equals -1 cubed, which equals -1. So again, it's -1, -1. So then f of 0 equals 0 cubed, which equals 0. So 0, 0. And then f of 1 equals 1 cubed equals 1. So 1, 1. All right, so then that's f of 2 equals 2 cubed, which equals 8. So it's 2, 1, 2, 3, 4, 5, 6, 7, 8. Just approximate the point there and connect your points. All right, now for domain and range. From left to right, this graph is infinite in both directions, or going infinite in both directions, so domain's all real numbers. In interval notation, we write that as -infinity to positive infinity. Now the range is going infinite in direction both from bottom to top, so we call that all real numbers. Or in interval notation, -infinity to positive infinity. And then that's cubic, so f of x equals x cubed. All right, so take a few seconds to update that. All right, now let's look at exponential. So again, you need to add the domain and range, inequality, and interval notation. And let's look at f of x equals 2 to the x power. So again, when negative 2 is x, we're going to plug that negative 2 in for x. So it's f of negative 2 equals 2 to the negative 2, which is 0.5. So that point is negative 2. 0.5 is about halfway, so you just approximate the middle. Okay? F of negative 1. So that equals 2 to the negative 1, which is 0.25. So negative 1, it's a little less than 0.5, so it's about right here. It's going to look like it's the same, but you just approximate because it's between 0 and 1. All right, f of 0. And actually, I'm sorry. My mental calculator here is broken. 2 to the negative 2 is 1/4. 1/4 is 0.25. And 2 to the negative 1 is 1/2, which 1/2 is 0.5. Looks like I need to change the batteries on my mental calculator here. All right, so then still that's 0.25, 0.5. In essence, they're so close, your approximation is going to look the same. All right, so f of 0 is 2 to the 0, which equals 1. So 2 to the 0, so that's 0, 1 is that point right here. F of 1 equals 2 to the 1, which equals 2. So that's 1, 2. And then f of 2 equals 2 squared, which equals 4. So that's 2, 1, 2, 3, 4. Connect your points. All right, so domain. From left to right, it's infinite in both directions, so it's all real numbers, which in interval notation, we write negative infinity to positive infinity. Now the range, it starts at 0, but it doesn't include it, and it's greater than. So that's y greater than 0. We don't put a line underneath because it doesn't actually read 0. Interval notation, we use a parentheses because it doesn't include 0, and it goes to infinity. Next exponential notation is f of x equals 2 to the x. All right. Now let's look at the next. Now we're looking at logarithmic. Now what I did was I actually moved the table down so we have space to write in this blank area, okay? And also don't forget to add the domain and range, inequality, and interval notation. All right. So f of x equals log base 2 of x. So now we're going to use x is 0.25. So that's f of 0.25 equals log base 2 of 0.25. Now, at this point, or any of the points, and you're wondering how to put that in the calculator, just ask me in class and I'll show you how to do that. But if not, we'll just go through with the values. So log base 2 of 0.25. Let me replace those batteries before I make my mental calculator, before I make a mistake, is negative 2. All right, so that point is 0.25. And again, that number is between 0 and 1, so you just approximate, and then you go down 2. Okay? Now let's look at f of 0.5, which equals log base 2 of 0.5, which is negative 1. So 0.5, negative 1. All right. Next one, f of 0 equals log base 2 of 0, which is All right, is undefined. And really, this value should have come up first, because you usually want your x values to, and I'm kind of glad I made a mistake, because so I can kind of go over this lesson. You want, whenever you're putting in x values in, you want the smallest number to the largest. So technically, we should put 0 first. Because now when we graph our points, we have to go backwards. You know what? Usually do that. You can still do it, but it would have been smarter to put the 0 on the first number. But 0 is undefined, is right here. So that means there's going to be a dashed line at 0, meaning that there's no value to find in there. Okay? All right, so now let's look at f of 1. Is log base 2 of 1, which is 0. So 1, 0. And then I have 0, 1, 2, 4, but let's just do 1, and let's do 2 as the last value. So then that's f of 2 equals log base 2 of 2, which equals 1. So there's your curve. All right, so domain, from left to right, it looks like it starts at 0, but it doesn't include it. So that's going to be x greater than 0. Now, in interval notation, that's a parentheses, 0 to infinity. And parentheses means it doesn't include 0. Now, range, it looks like it's going infinite in both directions, so it's all real numbers. Or in interval notation, negative infinity to positive infinity. All right, so that's f of x equals log base 2 of x. Now, at this point, you probably, if you want to do this video in 2 days, I'd probably stop. This is about the halfway point, and then finish the rest of the video the next day. Okay, but if you like, you just want to knock out the whole thing all at once, by all means, please continue now. All right, let's look at cube root. Okay, so cube root, again, I've moved the table down so we have space to work here. Don't forget that domain and range, inequality, and interval notation. All right, so cube root is f of x equals the cube root of x. So it's f of negative 8 equals the cube root of negative 8. Now, and again, if you need help with how to put that in the calculator, just ask me as you're watching the video in class, or just after you watch the video in class, and I'll show you how to put that in the calculator. But either way, that's negative 2. So your point is negative 8. 1, 2, 3, 4, 5, 6, 7, 8, negative 2. You just have to approximate your point. Okay. Now let's look at f of negative 1 equals the cube root of negative 1 equals negative 1. So negative 1, negative 1. F of 0 equals the cube root of 0, which equals 0. So 0, 0. So f of 1 equals the cube root of 1, which equals 1. So 1, 1. And f of 8 equals the cube root of 8, which equals 2. So 8, so 1, 2, 3, 4, 5, 6, 7, 8, 2, which is approximately right there. Connect the points. All right, now domain. From left to right, it's infinite in both directions, so that's all real numbers. In interval notation, that's negative infinity to positive infinity. And range, from bottom to top, it's infinite in both directions, so it's all real numbers. Negative infinity to positive infinity. All right, cube root, so that's f of x equals the cube root of x. All right, now let's look at, well, pause for a second so you can update cube root. All right, now let's look at square root. Again, I've moved down the table so you have space to work here. Domain and range, inequality interval notation. So let's look at f of x equals the square root of x. It can also be written as this. Most people don't put the 2, but I just wanted you to see that technically there's a 2 right there. All right, so that's f of 0 equals the square root of 0, which equals 0. So 0, 0. F of 1 equals the square root of 1, which equals 1. So 1, 1. And then f of 4 equals the square root of 4, which equals 2. So 1, 2, 3, 4 up 2. Connect your points. All right, so for domain. Domain is from left to right, starts at 0. So in inequality notation, we say it's x is greater than or equal to 0. And in interval notation, that's bracket, because it includes 0 to infinity. Range, again, at bottom, it starts at 0, so that's y greater than or equal to 0, because it's greater than. And then again, bracket 0 to infinity. And then square root is f of x equals the square root of x. All right, so I'll pause for a few seconds so you can finish up that. All right, now let's look at rational. Again, I've moved the table down so you have space to work. Don't forget to add domain and range, inequality, and interval notation. All right, so rational, f of x equals 1 divided by x. So that's f of x equals 1 divided by negative 2, which is negative 0.5. So negative 2, negative 0.5. All right, and f of x equals 1 divided by negative 1 equals negative 1. So your point is negative 1, negative 1. Now, f of 0 is 1 divided by 0, which a number divided by 0 is undefined. Okay, so that means there's an asymptote here at 0. Now, because you know there's an asymptote, once you know the point, you know the curve lies between the x and y axis here. Okay. So now let's look at f of 1. Equals 1 divided by 1 equals 1. So 1, 1. Again, once you know this point, you know that the curve will lie between the x and y axis. So rational looks like this, okay? But let's make sure that this point lies on that line. So f of 2 is 1 divided by 2, which is 0.5. So 2, 0.5 is about right there. So really, you could have just graphed it with these points, okay? You want to find out where it's undefined, and you need 1 point on the left of the asymptote and on the right. Okay. All right, now I'll give you a few seconds to update your graph and table. All right, now inequality notation. So domain, it's infinite from left to right except for at 0. So in the inequality notation, you would write all real numbers except x does not equal 0. Now in interval notation, we say that's from negative infinity to 0, not including 0, or 0 to infinity. Now the range is infinite from bottom to top except for at 0. So you would say all real numbers, y does not equal 0. Or in interval notation, negative infinity to 0, not including 0, or 0 to infinity. And then rational is f of x equals 1 divided by x. All right, so finish up rational. All right, now let's look at the last one. All right, absolute value. So again, I've moved the table down so you have space here to write that. And then don't forget to add domain range, inequality, and interval notation. So these bars right here mean absolute value. So that's f of -2 equals the absolute value of -2. Now, the absolute value means the distance from 0. So we don't care if it's negative direction or positive direction. We just care about the distance. So this is a total distance of 2 from 0. So the absolute value of -2 is 2. So our point is -2, 2. Okay. F of -1 is the absolute value of -1, which is distance from 0, 1. So -1, 1. F of 0 equals absolute value of 0, which equals 0. F of 1 equals the absolute value of 1, which is 1. So 1, 1. And then f of 2 equals absolute value of 2, which equals 2. So 2, 2. Connect your dots. All right, so there's your absolute value function graph. So the domain range. Now, domain from left to right is in infinite directions. So that's all the numbers, or in interval notation, -infinity to +infinity. But range, it's bottom is 0 and it's going to +infinity. So that's y greater than or equal to 0, or bracket 0 to infinity. Or the absolute value function is f of x equals the absolute value of x. All right, so at this point, you're going to finish up your parent function foldable. And then what I do to get it on the page is I'm just going to tape it down. You can glue it down. I just tape it the last page on the left, the right, maybe on the bottom. And then remember, this page is going to be on page 2 in your journal. Okay. So far in your journal, let's see if I can get this right. Camera there. So I have the table of contents for all the 6 weeks of mine. You only need the first 6 weeks. So the first page in the journal is your table of contents. Then page 1 is going to be the syllabus. And page 2 so far is your parent function folder. Okay, so make sure you're keeping your binders put together. And with that, have a wonderful Wildcat